we are reacting a weak base with a strong acid. We'll consider the strong acid to be simply hydronium ion in solution. So the relevant initial reaction is that we have our ammonia reacting with hydronium ion in a one-way reaction to produce the conjugate weak acid plus water. Before change after, the initial amount of NH3 is 4.0, and we've added 5.0 millimoles of HCl. So our limiting reagent is the ammonia, and it's going to consume 4 out of the 5 millimoles of hydronium ion. We don't have any of our weak base remaining. On the product side, we've generated 4 millimoles of our conjugate weak acid. In our resulting solution, we have some excess strong acid, and we also have some weak acid that was generated in the process of the neutralization. We need to note, however, that the weak acid is only going to have a negligible impact on pH because it's a weak acid, and almost all of it remains undissociated. So what we need to consider in our calculation is the strong acid that's in solution. To get a numerical value for the pH, we would calculate the concentration of the hydronium ion that's in excess and do the standard calculation.